Hello everyone. In this video, I would like to talk a little bit more about the sub procedure. So we have actually covered a lot for this, but still I think some of you, I got a couple questions in the past week. So some of you are still not quite clear about how to write the sub procedure, especially when you want to use the stack to store, temporarily store some variable value or register value. So let me give you just one more example, and then this will help you with the last problem for your lab. So remember that when we talk about a stack, and I told you there could be a lot of different things stored in the stack. And then what are those contents that's inside of this figure, right? So you could store multiple arguments value from for the subroutine. When you have multiple arguments value, you could store some registers value, you could store some local variable if it's really big. And most of the time, I have to tell you that we do not have that case. You have many arguments, or you have like a big huge local variable to store in the stack. So this is like the most complex case. If you have a lot of arguments and you also have a few registers, you have to keep that. And you also have a big array in your subroutine, and then you will use the stack to store all those things. But for us, you will never deal with an example like that, okay? But I just want you to know. And there was a really good question posted in the Google Sheet. If you have seen that, then if you haven't seen that, you probably want to check it out. So one student asked a really good question about, suppose I have multiple return values. Suppose I have multiple arguments to pass. When you have a main function, a sub function, and you want to pass for quite a few parameters, then what should I do? Then you have to use the stack. You have to use the stack to save those values, right? However, we do not have that kind of example. We do not have really complex example. But I do require you, so this is actually required in your lab, to understand you need to save certain register in the stack. You do need to save certain register in the stack. And then what kind of situation we need to save the register in the stack? So this actually come from this slide about the usage for those registers. So for all the lab before this lab, we only need to deal with the regular calculation task, and we don't need to worry about using the stack. So you can basically use whatever register you want, right? However, if you do have a subroutine, you do have a main routine, then we should have the convention for MIPS is then the S register that belongs to the main routine. The T register that belongs to the subroutine, so that belongs to different group. It belongs to different group. The S register that belongs to the main routine, and the T register that belongs to the subroutine. So what does that mean? So by default, by the convention of the MIP, suppose you have the main routine, you have the subroutine, right? So your main routine looks like this, and this is your subroutine. So you have to jump out from the main routine and go to some sub function to perform certain calculation. And then there will be one question here. Suppose I'm using like a register here, and then I'm using it again here, right? So your register may equals 1 at that time, and then you want to keep that value here because you want to keep using that in your main routine. And what will happen if you use it again here? It will be not safe. It will cause problem because you don't want to change the value of S0. Suppose you change the value of S0 in your subroutine, what will happen? That will affect the following calculation after the subroutine. Right? So by the conventional MIPS, then the S registers, they belongs to the caller, belongs to the main routine. The T registers belongs to the subroutine, right? So you should not use S register in your subroutine without thinking. without thinking, okay? You might be able to use that. And to be honest, I have to tell you, a lot of the modern compilers, they will detect whichever register was used in the main routine, whichever was used in the subroutine. So they will not cause any, problem. So even I use the S register in the subroutine, it will not cause any problem because I know which register is used, which register is not used. However, when we write the assembly code, then we just need to be safe, right? So in your lab requirement, I do require you to use the S register in your subroutine. And suppose you use the S register in your subroutine, then you have to guarantee you do not affect the usage of S registers of the main routine. So even you may not change the value. Suppose I use S2 here, S3 here, S4 here, So that means, the S register here are not used in the main routine, so there should be no problem. However, to be safe, what do we need to do? So always save the old value of the S register before you use them. Save the original value. So we're talking about, suppose we're doing the subroutine, and then we are thinking about to save the old value of the S registers in the stack before we use them. And then this is the first step. And the second step will be the regular required calculation. Required calculations. Finish the required calculations of the sub function, right? Sub procedure. So get everything done, right? Get everything done. And then the last step will be restore the old value. So you just take the old value out from the stack, right? Restore the old value of the S registers, right? So how you can restore them? So if you put them in a stack, then you just take them out from the stack. That's it, right? So for example, so the main routine want to perform the calculation, and then I have an integer x, I have an integer y, and then I call the sub function. So the sub function has the name sub function, like this. And the sub function has two input, x and y. And then the sub function returns integer y and c. So the sub function equals 1. Let me give them a little bit initialization, for example, and the integer c equals 0. And then the sub function use the x and y to perform certain calculation, and then the result, the return value is the c. The return value is c, right? And later on, you may want to have some other work using the c, like print the c out or whatever. And then in the sub function, what we do, so you have two integer input. One is integer x, one is integer y, right? And then in the sub function, then you just need to do, for example, if I have call it a and b, then the integer a plus b, and you want to return that value. Return a plus b. Return a plus b. So suppose this is the subroutine. So how can we write down the assembly code? Then the assembly code for this particular example, first of all, so in your main routine, then you just need to initialize the parameters. So get the arguments ready, So it's the main routines, it is the main routines responsibility to get the arguments ready. And you have to put the first argument in A0, okay? And you have to, so I'm writing a pseudocode, okay? And you know how to write that, the real code. You have to put the first parameter in A0. You have to put the second parameter in A1. And there was one question in the Google Sheet said, suppose I have multiple parameters, and then if I use all the A0, A1, A2, A3, and it's still not enough, then you can use the stack. Then you can put them in the stack, right? However, we do not have that kind of example for us. It will be too complex for the requirement for 2400. But you should know you do have other options. You do have other options, and so the main routine need to get the parameter ready before you jump to the subroutine. And then we just need to do jump and link, right? So we jump to the subroutine, and then you have another label, kind of like a sub function, for example. And you could start this in one file, and later on in another file. Suppose that's your subroutine, or if they are in one single file, it will look like this, right? So in your subroutine, what we need to do. So in the subroutine, then we just need to perform the calculation, right? So the calculation is A plus B. So that's actually the required calculation, and suppose I call it the middle part of whatever required calculation. So my goal is the required calculation is my second step. So the goal is to get A plus B ready and put it into V0, because we have to put the return value into V0. We have to put the return value in V0. And then what I need to do before I do that, because suppose I require you to use, suppose there is a requirement, is use as register in subroutine. And of course, you don't actually need to use as register because you have the two parameters here, which is A0 and A1. And in your subroutine, then all you need to do is add A0, A1, right? So all you need to do is add. I should add $A0, because $A0 and $A1, they are ready. They are ready for you to use. And you could just add them up, right? And however, suppose I ask you to do a little bit more complex calculation. For example, you need to add it by 10, or you need to first do A plus B and then later A minus B. So then you have to, suppose the calculation requirement here is a little bit more complex. And you might want to use some register to hold the temperate value. For example, if I need to implement A plus B, A minus B, and then I need to return the whole, the sum of those. So that my first step should be add A0, A1, and I should have another one, which is subtraction A0, A1, right? Because A0, A1 currently hold my input value. So I could have subtraction $A0, A1, things like this, right? And then I have to put the subtraction result somewhere, have to put the addition result somewhere. Suppose I want to use put the addition result into S0. And I want to put the subtraction result in S1. And later on, I just need to return the value of S0 plus S1, S0 plus S1. So this is the required calculation. Which is actually the second step of the subroutine. However, what is the first step? What is the last step of the subroutine? If you are using S registers, in your subroutine, then you have to make sure you store them in the stack. By MAPS convention, right? Because you don't want to mess up the main routine. Even you might not use them in the main routine. However, you need to make sure you need to guarantee to be safe, guarantee the main routine is not affected by your subroutine. And we are using the S register in the subroutine, so we have to make sure we don't mess up the main routine. We don't mess up the main routine, right? Just like this one. So if you're using the S register in the subroutine to be safe, then you have to save the old value, the initial value of the S register in the subroutine, in the stack. And then you could use them to perform whatever calculation. And after you finish your calculation, you need to restore the old value from the stack, right? And suppose we're using, so if I want to save, so to finish number 1 and number 3 in my subroutine, so this is my subroutine. And in order to get everything safe, and then I have to put S0. So my goal here is I need to save my $S0 and the $S1 into the stack, right? Temporarily store the initial value in the stack. And then restore the value after I finish my regular calculation. So my first step is I need 2 space from the stack. If I need 2 space, you could do subtraction or ADD, So I should change my SP by -8 because I want the stack pointer to move 2 words down. So initially my SP is pointing to this location, and I need to subtract my SP by 8 because I want the SP to move 2 words down, right? Because I need 2 space, 2 words for 2 registers, And then if I have those, so my current SP equals this value. And then the SP0, of course, will be my current SP0 will, of course, point to this location, right? So I can store, so because I need to put my register S0 and S1 somewhere. So I can store my S0 here at this location, And then I can store my S1 on this location, right? So what is the address of that location? It would be your subtracted, decreased SP add by 4, because this is SP at 0, then this will be SP add by 4. This will be SP add by 4, right? If you add it by 8, it will go back, right? So, and then I could perform whatever required calculation in my subroutine. And remember, this last step is always, the last step in the required calculation is always get your V0 ready, because that's the return value. The last step is always get the V0 ready. Because that's the return value. You have to put the return value in the V0, and that's the responsibility for the subroutine. And for the main routine, you have to initialize the A0, A1, the parameters, put the parameters in the A0, A1, A2, A3. And then in the subroutine, you just assume they are ready for you to use. And the subroutine also has the responsibility to get V0 ready, right? So the required calculation, suppose I call it number 2, then you just need to perform whatever calculation you want. And you could feel free to use S0, S1 because they're already stored. The old value of the S0, S1 are already stored somewhere in the stack. Right? And then the number 3, last step will be, well, if I finished my calculation, I don't need to use S0, S1 again, then I can restore them. So how can I restore them? I just need to load them back from the stack. So where I put them, where I just need to take them from, right? So I put this S0 in this location, then I just need to take it out. Right? And I put the S1 in this location, I just need to take it out. I just need to take it out from that location. So the same address, if you use 0 here, it's 0 here. If you use 4 here, it's 4 here. And it doesn't matter, you can store S1 in the SP0. You can store S0 in the SP4. You can switch the different location. You do whatever you want. But where you put it in, then where you take it out from. Where you put in, where you put it, where you take it from. Right. So after I restore them, so I need to move this back. I need to move this back, right? I need to move the pointer back to their initial location. I need to move the pointer back to the initial location. So what should I do? I should, because I did subtract it by 8, so I just need to add it by 8 again. Right. So this is actually the general 3 steps for your subroutine. Suppose you need to use certain register that belongs to the main routine. I know you should do this. You should first put them in the stack and then finish whatever required calculation. And the last step will be restore them from the stack, right? So you always need to follow the same procedure. And then if you use 3 registers, if you need to use 3 registers that belong to the main routine, then you need to take 3 space from the stack. And instead of subtract it by 8, then you want to subtract the SP by 12. So on and so forth. So you know how to change this, right? And then you might have a question, well, the subroutine want to use the register belongs to the main routine. The subroutine need to store them somewhere, temporarily keep them in the stack. So it is also true for the main routine, of course. Suppose the main routine want to use certain register that belongs to the subroutine, and then you might want to store them in the stack before you use them, and later on restore them from the stack after you finished usage of them, right? After you finish using them. So we don't have really super complex example in your future exam or lab or homework, whatever, but I think this particular example is like the most popular usage for stack to temporarily keep the value of a S register that belongs to the main routine. So I hope everybody could understand this. So, all right. I'll stop here and see you in next video.